Hello everyone, my name is Shani Naomi Whiteman. Today I'm presenting a prospective cohort study examining whether red and processed meat intake is associated with cancer. Diet is one of the most important modifiable factors in cancer prevention, and both red and processed meats have been studied for their potential carcinogenic effects. These meats contain compounds such as nitrites, heme iron, and cooking byproducts like HCAs and PAHs, all of which may contribute to cancer development through DNA damage or inflammatory pathways. Previous epidemiologic studies have suggested associations, especially with colorectal cancer, but the evidence has often been inconsistent due to smaller sample sizes, limited follow-up, or inadequate control for confounding factors. This makes large prospective studies essential to better understand the relationship between red and processed meat intake and cancer risk. Before the Cross et al. Study, several prospective cohorts had already suggested a link between red and processed meats and cancer, especially colorectal cancer. A meta-analysis by Chan and colleagues in 2011 pulled data from multiple large studies and found a consistent association, particularly with processed meat intake. This evidence across diverse populations support both biological plausibility and the need for continued investigation in large, well-designed cohorts. These earlier findings set the stage for why Cross et al. Carried out their study. Although earlier studies suggested a link between meat intake and cancer, many were limited by small sample sizes, short follow-up, and not as robust dietary assessments. These limitations make it difficult to fully adjust for confounding factors such as smoking, BMI, physical activity, and alcohol use, which commonly cluster with higher meat consumption. A recent evaluation by Handel and colleagues in 2021 highlights how these issues can weaken epidemiologic findings in meat and cancer research. This reinforces why a large, well-powered prospective cohort like the NIH AARP study used by Cross et al. Was essential. It allowed for more accurate adjustment, stronger statistical power, and greater ability to detect meaningful associations. This is the study overview conducted by Cross and colleagues. And this was a large prospective cohort study based on the NIH AARP Diet and Health dataset, which included more than 500,000 adults, ages 50 to 71 years old. Participants had to complete the baseline dietary questionnaire and be cancer-free at enrollment. Individuals with a prior cancer diagnosis, incomplete dietary information, unrealistic caloric intake reports, or who could not be linked to cancer registry data were excluded. The exposure was red and processed meat intake that was categorized into 5 intake levels, with the lowest intake group serving as the comparison. Outcomes included total cancer incidence and several site-specific cancers, and participants were followed for roughly 8 years. To frame the research question clearly, the PECO model is included here. The population was older adults who were cancer-free at baseline. The exposure was higher intake of red and processed meats. The comparison group was the lowest intake group, and the outcomes were total and site-specific cancers. This slide describes how outcomes were measured and which confounders were controlled for. Cancer diagnoses were identified through intake with state cancer registries. This allowed the authors to capture both total cancer incidence and several site-specific cancers with approximately 8 years of follow-up. The authors adjusted for important demographic and lifestyle factors, including age, sex, race, smoking, BMI, physical activity, alcohol intake, and total energy and fruit and vegetable intake. These adjustments strengthened the validity of the associations that were observed. This figure summarizes the key baseline characteristics from Table 1. Participants with the highest red meat intake tended to have a higher BMI, smoked more, were less physically active, and ate fewer fruits and vegetables. They also had lower levels of education. In contrast, those in the lowest intake group generally showed healthier lifestyle patterns, including more physical activity and higher fruit and vegetable consumption. These differences illustrate why confounder adjustment is essential in this type of observational study. And without controlling for these lifestyle factors, the relationship between meat intake and cancer risk may be misleading. This figure shows the adjusted hazard ratios for different cancers across increasing levels of red meat intake. What stands out is that the strongest associations were observed for colorectal, liver, esophageal, and lung cancers, where risk consistently increased as intake went up. For many of the other cancers, the hazard ratio stayed close to 1, meaning there wasn't a meaningful association. And you can also see the width of the confidence interval, which helps us understand how precise each estimate is, as wider bars reflect more uncertainty in the data. The study has several important strengths. It is a very large sample size, providing strong statistical power, and the prospective design reduces recall bias. Cancer outcomes were identified through state cancer registries, which improves accuracy. The dietary data came from a validated food frequency questionnaire, and the authors adjusted for a wide range of demographic and lifestyle factors. However, there are also limitations, and because it is an observational study, the findings cannot establish causality. Some residual confounding is likely, particularly related to smoking and meat cooking methods that weren't fully captured. Diet was measured only at baseline, which may miss changes over time. And self-reported diet always includes measurement error. The authors concluded that higher intake of red and processed meat was associated with an elevated risk of several types of cancers, particularly colorectal, liver, esophageal, and lung cancers. They also noted that many other cancers showed no significant relationship. Overall, the authors suggest that reducing intake of red and processed meat could potentially decrease cancer risk across multiple sites. And for my clinical bottom line, the evidence from this very large prospective cohort suggests that higher intake of red and processed meat is associated with increased risk for multiple cancers, particularly colorectal, liver, esophageal, and lung cancers. Although observational data cannot establish causality, the consistency of results and clear biological mechanisms behind them add credibility to these findings. Clinically, it is reasonable to encourage patients to reduce processed meat consumption and adopt a more whole food, plant-based dietary pattern to support long-term cancer prevention. And these are the references for my primary article and 3 supporting studies I included in the presentation. They provide additional context and help strengthen the evidence behind the findings that were discussed. I thank you for your time. Thank you.